Hello, welcome back. Today we're going to be talking about the distributive property. The objective is that by the end of this video, you should be able to use the distributive property to simplify an algebraic expression. Remember, an algebraic expression is just an expression that includes numbers and letters. Now, for the first example, we're going to do something we've done in the past. We're going to simplify 3x times the parentheses 2x squared minus 4. As we look at it, we notice that we have to take the 3x, since it's outside of this first parentheses but right next to it, and multiply it by both terms inside of the parentheses. So the first thing I'm going to do is I'm going to multiply 3x and 2x squared. When you multiply two terms, you multiply the coefficients, the 3 and the 2, to give me 6 and x times x squared. Now x has an exponent of 1, so x to the first times x squared. You add the exponents to give us x to the third. Then we distribute, or rather multiply, the 3x and the negative 4. 3x times negative 4 gives us negative 12x. So again, we took the 3x and distributed the 3x, or multiplied the 3x, by both terms inside of the parentheses. Quick review, terms are anything separated by a plus or minus sign. So 2x squared and the negative 4 were two different terms. This is our answer. Notice we cannot combine the 6x to the third and the negative 12x because they do not have the same exponents. Like terms are the same letters with the same exponents. We're going to start off by talking about what distribution looks like if you have more than one term. If you have more than one term in both sets of parentheses, we must multiply every term in the first set of parentheses by every term in the second set of parentheses. When we write our final answer, we must always write our answers from largest exponent to smallest exponent. Now we're going to simplify this expression. Notice in the first set of parentheses, we have two terms, 5 and negative 3x. In the second set of parentheses, we have two terms, 2x and a plus 4, or positive 4. And what we just got through writing says we're going to take these two terms and distribute them to the two terms in the other set of parentheses, meaning we're going to multiply a total of 4 times. There are a couple ways we're going to go about doing this, and these methods really are just ways of keeping track of that multiplication. Because the longer these problems get, the more multiplication there is, and the more necessary it becomes for us to keep track of it. Now, the first method is going to look a lot like a Punnett square. Let me show you. We're going to go ahead and draw a box, and our box is going to be split up into 4 sections. And the reason for that is for our first set of parentheses, we have a 5 and negative 3x, so we're going to rewrite those terms outside the box right here. 5, negative 3x. And on the top, we get a 2x and a 4. Now, kind of again like the Punnett square, we're going to take these terms, and where they meet each other, we're going to multiply. So the 5 and the 2x multiply together to give us 10x. The 5 and the 4 multiply together to give us 20. The negative 3x and the 2x multiply together to give us negative 6x squared. Remember again, it was negative 3x to the first, 2x to the first. And when you multiply those, you add their exponents. 1 plus 1 gives us 2. And finally, the negative 3x and the 4 meet together in this square to give us negative 12x. Now what we're going to do with this is we're going to rewrite our expression out of the box. And we're always going to start with our largest exponent. So we write negative 6x squared first, because that was our largest exponent, the squared. Then you'll notice that you have two terms that have an x on them. 10x and negative 12x. So we're going to go plus 10x minus 12x. Now it doesn't matter which order you write that in. Could be minus 12x and then plus 10x, because we're going to combine those here in a moment. And our last number is 20. So before we're finally done, we go ahead and combine any like terms that we have. Negative 6x squared. 10x and negative 12x combine to give us minus 2x. And then we get a 20 at the end. Since the 20 has no x, we list that at the end as our constant. And writing it from largest exponent down to smallest exponent is called the standard form. Now this is the first method of distribution. There's another way we can go about solving, or rather simplifying, this expression. Let me show you. We can also, and this requires less writing, take the 5 and draw an arrow from the 5 to the 2x and write the result. 5 times 2x is 10x. Then we can take an arrow from the 5 and write it to the 4. Positive 5 times positive 4 is positive 20. Then we could take this. Now, what's tricky about this term right here is it's a minus 3x. So the sign of that 3x is negative, which means when we take that negative 3x and multiply it by the 2x, it gives us negative 6x squared. Then we're going to take the negative 3x and distribute it to the 4, giving us negative 12x. So, just like the other method, we end up with a statement or a series of letters and numbers written out, and we're going to write it from largest exponent to smallest. So negative 6x squared comes first. Then we're going to combine our 10x and our negative 12x, since that's the next largest exponent. 10x and negative 12x give us negative 2x, and that leaves us in the end with a plus 20. So those are the two methods we're going to use to distribute, and it's really up to you which method you want to do in order to simplify expressions like these. Alright, so now I want you to try to simplify the following, and I want you to use your favorite method, then check your answer using the other method. If you get it wrong after you played the video, so you paused it, you worked it out, and you play it, as soon as you see the answer, I ask you to go ahead and pause the video and try to work it out by the other method before you see it worked out. So again, go ahead and pause the video, work it out, and press play when you're ready to see the answer. So I went ahead and got us started with this Punnett square or the box method, and I'm going to show you the distribution in this example. 3x times 2x gives us 6x squared. 3x times negative 6x squared gives us negative 18x to the third. 4x squared times 2x gives us 8x to the third. And 4x squared times negative 6x squared gives us negative 24x to the fourth. Remember again that if there's no exponent, the exponent is 1. And when you multiply like bases, you add the exponent. So this is what we ended up with, and I'm going to go ahead and write that out, smallest to largest exponent, largest to smallest. And I'm going to start with that negative 24x to the fourth, since it's got the largest exponent. So negative 24x to the fourth. And if you want to, you can always combine your like terms and then write them. So 8x to the third and negative 18x to the third gives us negative 10x to the third. And we're left with, in the end, plus 6x squared. And there you go. Using the box, the Punnett square method, we end up with negative 24x to the fourth minus 10x to the third plus 6x squared. Now I'm going to go ahead and show you by the other method. I take the 3x, multiply it times the 2x, gives me 6x squared. 3x times negative 6x squared gives me negative 18x to the third. Because x to the first times x squared, you add the 1 and 2, get a 3. And then I'm going to take the 4x, multiply it times the 2x. So 4x squared times 2x gives us a positive 8x to the third. And 4x squared times negative 6x squared gives us negative 24x to the fourth. Now all I have to do is combine my like terms. I'm going to use a separate color to signify that. I have a negative 18x to the third and a positive 8x to the third, so I can combine those. So when I write my final answer from left to right, largest exponent to smallest, I'm going to write the negative 24x to the fourth first. Then I'm going to combine the negative 18x to the third plus 8x to the third, give me negative 10x to the third. And then I have a positive 6x squared left over. And there you go. We have distributed using the other method of keeping track of our multiplication. So we're going to take this whole idea and we're going to extend it to a much larger problem. Negative 6x minus 3 plus 4x squared times negative 3 plus x to the third minus 6x. So there are three terms in both of those sets of parentheses, and we're going to have to multiply all three of terms in the first parentheses by all three terms in the second. When I have a problem this long, I like to go ahead and use the box method because it just seems easier to me to keep track of my work. You can choose either method. Go ahead and press pause and try to work it out on your own, and press play when you're ready to see the answer. So when I make my box, I am going to need to make it a little bit larger than usual. And I'm going to need to make it a 3 by 3 box because I have three terms in both sets of parentheses. So 3 on top and 3 on the side. So I get negative 6x on this side, negative 3, positive 4x squared. On the top I get negative 3, x to the third, and negative 6x. And then I'm just going to go ahead and match up where the two terms meet. Like negative 6x meets negative 3x, and they multiply, so we get 18x. Negative 6x and x to the third gives us negative 6x to the fourth, because again, an exponent of 1 plus 3 gives us an exponent of 4. Negative 6x to the first times negative 6x gives us positive 36x squared. Negative 3 times negative 3 is positive 9. Negative 3 times x to the third is negative 3x to the third. Negative 3 times negative 6x is positive 18x. 4x squared times negative 3 is negative 12x squared. 4x squared times x to the third gives us 4x to the fifth. And finally, 4x squared times negative 6x gives us negative 24x to the third. So now that we have this fairly large mess, we're going to need to write it from largest exponent to smallest exponent, combining our like terms along the way. So first thing I'm going to need to do is identify my largest exponent. So I look through all the boxes and I notice I've got an x to the fifth. So I'm going to write the 4x to the fifth first. Then I look through, and I'm going to use a separate color to show this. I'm going to look through to see if I have any x to the fourths, because that would be the next largest exponent. And I notice I've got a negative 6x to the fourth. And as I look through, I don't see any other x to the fourth, so I just write minus 6x to the fourth. And then I look for x to the thirds. So I notice I have a negative 3x to the third and a negative 24x to the third. So I match those up, combine those like terms to give me negative 27x to the third. Now, I'm going to end up writing this answer in the end down below. So for right now, I'm just going to make it one line and continue it down here. So going to my next largest exponent, I've got squares, so I look for any x squareds. I notice I have a 36x squared and a negative 12x squared, so I combine those to give me 24x squared. I notice I have two 18x's, so running out of colors, I'm going to get this 18x and this 18x to give me plus 36x. And in the end, I've got a 9, so I'm going to write plus 9. So I can't combine any of these like terms or any of these terms because they're not like terms. They're all x's, the first 5 terms, but they don't have the same exponent, so I can't combine them. So in one color, I'm going to write my final answer, 4x to the fifth minus 6x to the fourth minus 27x to the third plus 24x squared plus 36x plus 9. And that is a huge polynomial, but fairly straightforward so long as you keep track of your work. Might be a good idea as you work through these problems to have some map colors out to help you match up your like terms as you move along.